Choose one.
Okay, so time for visualizations. So we want to see the top, which counties have the largest populations. It's 58 counties. Ideally, let's just look at the first 15. We'll get a general gist from just those 15. And so that's going to be our gist. So we're going to create a data frame called top county data frame. We're going to look at the descending order of the population. Okay. And so just look at the first 15 of those. Okay, run this. Run this. Okay. And then if we go here to look at the data frame, you see only 15 counties, and it's arranged from least to greatest, or greatest to least. Greatest to least. That's that. Now we want to actually plot this. So this is going to be population. Okay, we're going to put our population on the x-axis. Spell it correctly, and then we're going to first put is the county, and then by population we're going to order it based off of the population size. County, and then by population. Okay, so this is not going to work if you run it because you haven't installed a new library called scales. So you do the install.packages scales. Okay, that will allow you to install the capacity, or at least utilize the functionality to put commas in the numbers. So I'm going to comment this out. I'm going to assume that you installed that, but I'm going to comment this out just so you can see how this does not look good because it used scientific notation to display the numbers. So you see the graph looks nice, right? But then on the x-axis, it has scientific notation. So what we can now do is use the scale x continuous function, and then within it describe the labels to have commas within it. We can now, where did I mess up? Right here. To now have get rid of the scientific notation and actually see the actual data. See the actual commas within the x-axis. This looks nice. It looks nice. Okay. So how could you articulate that using words? It formats large numbers with thousands. That was pretty bad. Thousands. Separator, commas. Okay, so that's what it allows us to now do, which is really, really useful in terms of making our graph look presentable. The next question, or at least the next thing that we're now able to do, is to talk about, or at least to address, what does the distribution actually look like? So we can create a histogram. Is it histogram? It is histogram. So what we're going to do is filter out NAs, which I'm pretty sure we don't have any, but it's still fine to do so. We'll say population, and then our x-axis is going to just be population. And when we graph this, I'm actually going to comment this out and see what this looks like, and it will ask a statistical question. All right, so with that being said, this ideally not ideally, it's going to be skewed right. Skewed right, exactly. So the tail's to the right. And so this doesn't look ideal. And so what we can do is perform a log base 10 transformation. Oh, this is log 10. Okay, log 10 to the x-axis to be able to, make this look more symmetric and unimodal. And as well, we can also add those commas too with this functionality here. So if we go ahead and run this, right now it's more symmetric because we applied a log base 10 transformation to our data. So if we want to get a better sense of what log base 10 does, if we have 10,000, this makes 10,003. Or 4, sorry, that's embarrassing. It makes a log base 1,000, log base 10 of 1,000, 3. And if you are, LA, that's 10,000, 100,000, 1 million, 10 million. That makes it 7. Okay, so it's not as crazy in terms of the numbers. Okay. So why is a log scale useful? Okay, why is the log scale useful? It allows us get my so county populations are strongly right skewed. A few counties have large populations, so it is a mechanism to compress our values to be closer to one another. Okay. And the reason why we filter out the NAs, I didn't delete it, did I? No, I didn't. Okay. The reason why we filter out the NAs is so that we can remove any missing population values. We didn't have that be a problem. But it's good to be cautious if you had to like do this again, and you could have some missing values. All right. So last but not least is to be able to answer this last question around how are California county area and population related. It's not that crazy. We're going to use a new visualization type in this series from the ETV perspective and create a ggplot. It's not a ggplot. It is a ggplot. A scatter plot, okay, where our x-axis is going to be county. So our x-axis is going to be area and our y-axis is going to be population. But we're going to filter them out. So we're going to just make sure that there's no NAs, even though I know that they're not. Population, and then we're going to do area, I think in area and square mileage. Okay, and then for x we're going to put area and square mileage, area and square mile, and then we'll put population. And as you can see, what I'm doing something a little different that you probably haven't considered is I'm changing the color of the actual points. I'm making this alpha allows me to make the points more translucent. So this allows you to see the transparency, the alpha level, and then the size is the actual size of the point. Since we're going to say x is continuous, allowing it to have commas as well, letting y have commas, but using the log base 10 scale, and then plotting it, and it looks something like this. Looks pretty clean. This has to be interesting. This is a big county. So we're on 20,000 in square mileage. Let's look at what is that county, just for some further, insight. We have time. That is San Bernardino. I should have guessed it. Okay, in terms of population, it's pretty large in terms of people, and also in terms of square mileage. And then this is LA. Wow, it is not that big. Okay, so it's not a linear trend, but you can kind of see that even when if you were to remove this point. Let's remove that point. I'm gonna move this and take this out of this function. Okay, and then I'm gonna do another filter. I'm gonna say filter, let's say square mileage. Is this square mileage? It's area, square mileage, less than 20,000. Okay, then pipe this into the plot. Okay, so press enter here so it looks a little bit better. It should still run. Filter. I forgot a parentheses. Okay, filter. This should be a plus. All right, now I got it. Jeez. Okay, so now even with that point removed, it does kind of seem linear over here to an extent, but not really. It's still a random scatter. Okay. Well, random scatter. So it's not really a big association between square mileage and size of the county, or the number of people in the county, even when it's actually compressed. So that's interesting. So if you want to, why don't you do some further investigation with this information, with this county data, and see what you kind of plot you can create, and put your comments below on what you are able to create. Thank you.